Welcome back to our live training session here with our Honda K24 swapped Civic Si. Now, this training module, we're going to get our engine to fire up and run and actually start to drive our vehicle. Welcome back to our live training session. We're going to be taking a look in this training module how to dial in our part throttle cruise area of operation. So we're going to be looking at how to dial in our volumetric efficiency table values here from roughly 80 kPa and below. We're also going to be taking a look at dialing fuel injection timing, so we can get that sorted out. We're going to be taking a look at setting up and tuning our estimate table. That's going to be for the map sensor failsafe or backup. We're going to be making sure we've dialed that in from 80 kPa and below as well. And then finally, we're going to be looking and talking about how to set up our variable valve timing control so that we have proper variable valve timing in part throttle conditions for a Honda K series engine. We're actually going to go and take a look at that first in order to get all that configured and set up so that when we're doing our actual part throttle tuning here in the volumetric efficiency table, we don't have to worry about going back in and then dialing in the volumetric efficiency table after variable cam changes. We actually can take care of that first, set the variable cam target to where we want, dial the VE table around that variable cam target because that changes the cylinder filling and changes the torque production of the engine, which affects the volumetric efficiency. So we're going to go about this in a very specific manner. Now, we also have our spark timing here in part throttle conditions. Let's just briefly talk about that, and then we'll move into variable valve timing, how we're going to be dealing with it. So in our spark timing table, we wanted to set values that were reasonable so that we didn't have to worry about knock or pre-ignition occurring, but gives us good drivability and reasonable power output out of our engine. Primarily, we're worried about essentially 80 kPa and below for right now because we're in part throttle conditions. At idle, I put my values here at 20. This acts as the ceiling for the upper limits of spark timing feedback and control in the closed loop spark timing feedback for idle control conditions. So this is fine. But once we drive off idle here around 3,000 RPM, we have our values here at 30 degrees. Now this is going to be a pretty solid value for pretty much any engine. We most likely can run more advanced in this in our spark timing table, but for right now, it allows us to focus on dialing in our airflow first. We can come back into this later, much later, probably the last thing in the training module here, and take a look at how to dial this in utilizing our mainline chassis dyno. Now I'm going to be talking about techniques to do it on a dyno, also techniques to do it on the road, so we can do it either or if you don't have access to a chassis dyno. Let's jump in here from the values that we've just talked about here, just kind of where the table's at and where we're at for the spark timing. We've parked it at safe, good values. Let's jump now into variable valve timing. We have a lot of setup that we need to go in and look at and talk about there. So let's go to our inlet cam VVT. This is going to be where we command and control everything. Now we have in our inlet camshaft target table, this is where we want our cam to rotate to in the closed loop control for variable cam control. Right now it's zeroed out, meaning it's in the neutral position. We have no increased overlap. When we start to have positive values in here, 10, 20, 30, 40, 50 degrees, that's going to be inducing more overlap. That's beneficial for part throttle and definitely beneficial for full throttle. What we're going to find here is that pretty much every Honda K series engine, regardless of whatever camshafts you have installed, in part throttle, we should cruise right around 30 degrees in our normal vacuum range. So probably from about 30 to maybe 70 kPa here, we'll be cruising in around that 30 degree range. So we need to make sure the variable cam timing is stable and it works and it's set up. So we need to make sure the feed forward value here is solid. We need to make sure the proportional, integral, and derivative gains are allowing the variable cam to track to the desired target. I'm going to walk through how to set that up here. So we know the last training module, we sorted out the drive-by-wire control, the idle control. We know the engine can crank, fire, and run and hold its idle. Now we're going to take a look at moving off idle and being able to deal with operating beyond that point. So when we're talking about variable valve timing, we want to zero it out at idle conditions. So between 0 to 1,000 RPM, 100 to 0 kPa within this table, that way I've set the breakpoint scalars, we're going to keep our values here at 0. When we start to drive off of idle, that's where we're going to start to introduce some overlap with the cam. Now we want to be specific with this. I am running OEM Honda cams, so the way I set this table up is going to be a little bit different than the way I would set it up for aftermarket cams that are hard on the factory tensioner or even upgraded tensioners. They can break the timing chain tensioner, cause you to skip timing and have valve to valve and valve to piston contact, all things we want to avoid. So how do we set this up? When we're talking about part throttle, again, between 80 to let's say 30 kPa, we want to be right around 2,500 RPM and higher, around 30 degrees advanced. So I'm going to say here, 30 to 80 kPa, 2500 and beyond, I'm going to set all of my values here to 30 degrees spark timing advance. Then between 1000 and 2500, I'm going to go ahead and do an interpolation and click H. That's going to allow me to start to advance the cam progressively as my engine speed picks up. Low engine speeds, if we have too much overlap, that's going to cause a lumpy idle and cause idling problems. Also drivability problems. When we start to get up here 2500, 3000, we want to run essentially the most advanced when we want to go in and operate in part throttle. Now my variable cam gear itself mechanically can go to 50 degrees. I'm not going to go past 30 degrees. This seems to be the sweet spot to be able to give us good torque production out of the engine and throttle response, but not have a hit to fuel economy. So I'm going to park it at 30 here. Now, I'm going to go and shape this a little bit. So I'll say here from 30 to 10, I'm going to grab my values and I am going to go here and do Control H. I'm going to taper them down. So when I get here at about 0 to 10 kPa in the met pressure reading, that's going to be my overrun vacuum conditions. I want the cam to rotate back to 0, and when I come back on the throttle, I'll have it rotate back to the target of 30. This is fine for OEM cams. Aftermarket cams, we have to go and not allow it to actually rotate back to 0. You'll park it here at whatever your value here is at 30. So you'll lock it at 30 degrees as you're coming off the throttle, coming back on the throttle. That'll give you a little bit more jerky on-off throttle feel. However, it will not be as hard on the timing chain tensioner. As we're rotating the cam and allowing it to actually move and creating that overlap, it's going to put a lot of stress on the timing chain tensioner with a K-Series engine. Other engines are going to respond differently. So a 2JZ VVTi engine, for example, doesn't really matter. I typically zero it out and do this type of function as we're finding right here. It improves the on-off throttle feel for most variable valve timing engines. But a K-Series are notorious for beating up the timing chain tensioners with aftermarket cams. So I have OEM cams. This is not a concern. I don't have to worry about hurting the timing chain tensioner. So what we'll find here is I'm going to run my values as we see in the table. Now at 90 to 100 kPa full throttle, I'll leave this at 0 right now. When we get into the full throttle low cam tuning in the next training module, we'll talk about how to deal with adjusting our variable cam timing and then ultimately adjusting our high RPM values here. I'm only going to really focus on part throttle tuning from, let's say, 6 to 6,500 and below. I'm not going to go all the way out to 7 to 9,000 in this training module. I might touch that up at a later point in time, but for right now, we're really going to focus on where I actually going to operate my engine in typical part throttle conditions. So we've set our values in here. Taking a look, we've also set in our bank 1 control the position resource, the output resource. When we fire off the engine here, we're going to have to determine the offset value. The offset, if we take a look at the actual position, this is going to give us a position, this is going to give us the target. At idle, the target's going to be 0 coming from our idle area here. We should find the position of the cam is also tracking to 0. Most times we're going to have to use an offset value here and being able to put a value to offset so that when we command 0 in the cam advance, we're actually seeing 0 on the position of the cam. If we're finding that it's not tracking to the 0 position, the neutral position, it means we have a discrepancy. We need to fix that. Otherwise, the cam control will be inaccurate and cause us a lot of problems. The other thing, if we take a look here, we have a smoothing function. We'll have to see if we have to smooth this. Usually between 5 to 20% is usual for smoothing. That just smooths our signal out. So it's not going to, if we start seeing kind of oscillations in it, it's not going to allow the closed loop to chase that and create erratic control in the closed loop behavior. Looking throughout the rest of our variables here, we should find that the rest of the variables that we've programmed here are accurate in terms of the control and setup. We're really going to be focused on setting up the offset, the smooth.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here. And you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.